Welcome everyone to this new video tutorial. We're going to see today how to detect objects using feature matching and homography. So let's take this example. This is the image that I want to detect in real time, and this is the book, the same book that I have. What are we going to do? We're going to track the features of this image and the features of the real-time video. We're going to compare the features, so where from this image these points are in this image, so we can detect many features of this book. Once we have these points, then we can find what's so-called homography. The homography will give the chance to detect the exact book. All the exact image that we have here will be detected here, even keeping it in a different position and with different perspective. Let's start typing the code. We import CV2, import numpy as np. So first let's load the image. The image is equal to cv2.imRead, and the title is ultimo_sopravvissuto.jpg, and you can download this image from the link in the description. Or even better, you can use your own image and then you can take the book if you have it and try to do it in real time by yourself. And we need to load the image in grayscale format, so here we type cv2.imRead_grayscale. Also we need to load the camera, so cap is equals to cv2.video capture 0. Now we need to run the while loop to show the video in real time. Underscore frame equals to cap.read, so we read the camera, and after we want to show both the images and the frame in real time, so cv2.imShow image, which is emg, and then cv2.imShow, and let's show the frame and frame. The key event, so that we can press some key on the keyboard and we can stop, we can get out of the loop and close the video. cv2.wait key 1. If key is equals to 27, which is the S key on the keyboard, then we break the loop. Once we break the loop, we need to release the camera, cap.release, and finally cv2.destroy all windows. Let's see if everything is correct, and it is. First thing, now we need to track the features of the image and the video. So on the image, actually let's do it here. So features. To detect the features of the images, we have different algorithms, and I've explained this in some other tutorials, so I suggest you to check it if you haven't done it yet. So we need to load the algorithm. We're going to use the SIFT algorithm. SIFT is equal to cv2.xFeatures2d, and then SIFT underscore create. We're going to detect now the key points and the descriptors of the image, so we're going to do that here. So it's key points image is equals to sift.detect and compute of the image, and if we have a mask, we can pass a mask. We don't have a mask, so we say none. And the same we need to do with the frame. And keep in mind that we are going to use the grayscale format for both. We have already grayscale image as we loaded it in grayscale format. We need to convert the frame to grayscale. So gray frame, let's call gray frame equals to cv2.cvt color frame cv2.color underscore bgr to gray. Once we have the frame in grayscale format, we can do the same as we did for the image. So we need key points of gray frame and descriptors of gray frame, and it equals to shift.detect and compute the gray frame and no mask. And here I did a mistake. I forgot to say the descriptors of the image. Once we have that, we can check if we are detecting them correctly. So we can draw the features both on the image and on the gray frame. So let's do that. Let's draw here on the image. So it will be cv2.draw key points on the image. The key points are kp underscore image. The outer image is emg. The color, let's leave it on the emg. That's enough. Let's see if this works. Something is wrong probably. Let's type emg is equals to, so that it returns again the emg with the features. Okay, now we have the features of the image, and I need to say, so that it will be more clear when I talk later, that this is let's call this first image query image, and then the frame will be train image, because we're going to compare the frame with the query image. But the query image is we are taking the entire image originally, and on the frame we are taking only some parts. So it from this is the base, and from this we detect this. So it's good to know the difference, to call them with the proper words. Allora, I talk in Italian. So gray frame. Let's do the same, draw the key points on the frame. So gray frame is equals to cv2.draw key points on the gray frame. The key points are key points gray frame, and the outer image is gray frame. Let's show, instead of frame, just gray frame. Let's see. It's running really slow. Okay. And you can see, of course, we're detecting the features of the entire frame. So it's working really well for both of them. This was just an example to show you how it works. We don't need to draw the key points, so we can delete this draw key points. Now what we need to do is to detect the features. So what key points on the query image are on the train image. So we need to start the feature matching, and also we have watched in some previous video how to match the features. So if you haven't done that, I suggest you to watch it. In the previous video we used the ORB match detector. We're going to use FLAN because it's faster. I'm not going to get in details how it works. It's just necessary you understand that this algorithm detects the features that match the feature in both images, query image and train image. So let's do that. So flan is equals to cv2.flan base matcher, and we need to pass the settings of the algorithm, which are index params and search params. And as we pass this, we need to define them before. Index params, it's a dictionary, so dict, and these are just the setting of the algorithm. Algorithm equals 0 and trees equals to 5, and the search params is equals to empty dictionary. So here we load the object, the algorithm, and now after we have the key points and descriptor of the image, we can draw the matches. So we can say matches, let's call it EMG3 is equals to cv2 dot match. Sorry, I don't even remember the function right now. Okay, draw matches. Yeah, I found it. Draw matches. So let's follow this. Draw matches of EMG key points of the image 1, so it's key point image, then EMG2, which is the gray frame, and the key points of the gray frame, key points gray frame, the matches, and the out EMG, let's say gray frame, and that's all. And I forgot that to draw the matches, first we have to find the matches. So we need to use the algorithm. It will be matches is equals to flan dot knn match, and it is going to compare the descriptors of both images. So we have the descriptors of the image and the descriptor of the gray frame, and k in this case it's equals to 2. One more thing, as we might get many false matches, actually let's see what we get. Let's run the code if it works right now. Expected image, no, I have to, okay. It doesn't run. Probably I have just to, let's take just the good matches as following the docs. So good equals to empty array for m and n in matches. M and n. So in matches we have 2 arrays, m and n, inside matches. M is the query image, so the original image of the book, and n is the object from the train image, which is in this case the gray frame. We are going to compare the distances, so m.distance and n.distance. This is the so-called ratio test. When the distance from these descriptors, the lower, the better is the match. So to avoid getting really bad matches or really false, many false results, we're going to take only the descriptors and that have really short distance between them. So let's let's multiply and distance per like 0. Let's try 0.8, and let's see what we get. So we append the result to the good points. So we append m to, let's call good instead of good points, so it will be more clear for us. And let's do this, good points only, and let's run it. My computer unfortunately is running really slow right now. I have no idea why. And I forgot, I have to show EMG3. So let's not show the original image or this one. Let's just show show the EMG3 and EMG3. I think it's so slow because I'm also recording the screen and it's really heavy, this code. When I was testing it, it was going fine. Right now it doesn't. Okay. As you see, we get many false matches. Now I have the book and there are so many good matches, but when I take out the book, it's like detecting my face and the walls and many other things. And we don't want that. So let's decrease the distance. Instead of 0.8, let's say 0.6. And let's try that again. Now we are getting less features matching, but if I take out the book, we get really few false matches, and it's okay. It's what we want. So 0.6, it's good enough for us. We get only 3 or 4 false matches, as you see these lines, so it's okay. We don't need to draw the matches, so I will just comment this one and comment this part that shows the matches. Now we get to the interesting part. Once we get these points, we can finally find the homography and detect the object. So it will be just, let's say, homography. And this is actually just a comment for people who don't know. When there is this asterisk, it means it's a comment, it's not doing anything. You can type whatever you want, it won't make any difference, just for readability purposes. If the length of good points, so in this case we are going to say if there are at least 10 points, then we're going to draw the homography to find the homography, otherwise we are not going to do that. And 10 points is good. So if we find at least 10 matches, we draw the homography. we need to find the query points. Query, let's call it query pts is equals to mp.float 32. This is just the format that you want to extract, so I'm not going to get into details about that. Open the array. So from the key points of the image, m dot query edx dot pt for m in good points. We are basically extracting the position of the points, and these are the points of the query image. So inside the good points, as I said, there is an object for both for the train image and for the query image, and each object has a few, let's say, parameters. So like the distance which gives us the ratio, like how good is the match. We can find how good is the match comparing the distances. And then the other one is the query index. The query index gives us the position of the points of the query image. And so we're going to extract these points, and we need to convert this reshape. Convert is not the proper word. Reshape -1, 1, and 2. So this is basically just the way you are going to change the format of the array, nothing else. Actually, let's show. I want to show you an example. So print query points. Oh, it's so slow. It shouldn't be so slow for you. Okay, these are the points. And when we do reshape, I cannot even type reshape -1, 1, and 2. So let's take a look here. They are like just a simple array, and when we do the reshape, you can see it's changed the disposition. They are like array of array. Now let's take the points of the train image. So let's call it train points pts. It's equals to np.float 32 array k point gray frame m dot, it's not query index, but in this case it's train index, train edx for m in good points, and in this case again dot reshape. So it's like before 1 and 2. Once we have this, we can find the homography. So cv2.find homography with query points, train points, and this is the algorithm. I'm not going to get into details about this algorithm, just pass this cv2.ransack and 5.0. Here we get the matrix and the mask. Why we got the matrix? So that we can also show the object in his perspective. For example, key points. Sorry, one moment. There is some mistake somewhere. Key points gray frame. I found the error. Was line 34. Here it was missing .pt. And So I guess that now it works. It works without any error, so we can continue with the rest. So we get the matrix and the mask. There are a few things that we need to work on right now. The mask, from the mask we need to extract the points and put them into a list. So we have the numpy function to do that. So we have mask is equals to mask.ravel and then to list. Just easy as that. From the query image we need to get height and width, and now this is for the perspective transform, so let's call it perspective transform. We need to do all of that. I've done a video about perspective transformation, so if you watch that video it will be more clear what I am doing right now. Image.shape, so we get height and width. The points are this, np.float32, and we start from 0, 0, from 0 to the height, then the width and the height, and finally the width and 0. Dot reshape -1, 1 and 2, and now we can apply the perspective transform with this point. dst is equals to c2.perspective transform the points and the matrix. So basically in this perspective transform we are passing the points with the height and the width of the original image, and then it will adapt them in the new image. So this is all for detecting the homography. So now we can draw the lines on the object detected. Let's call it, let's do this way. Homography is equals to cv2.polylines. Let's draw them on the frame. And now we need to pass the points, but with integer, int 32 est, because as you know the pixel can be only integer number. You cannot split the pixel into something. You cannot have like 3.75. You can just have 3 or 4. So that's why we need to convert all the points that we get into integers. So that's with here. Polylines, true, we want to close the lines. The color, let's draw them in blue. So BGR format 255 of blue and 0 of green and 0 of red. Thickness 3, and that's all. So if we have the homography, we show the homography. cv2.im show homography else cv2.im show homography, and we just show the, let's show just the gray frame. That's all. Let's run the code. you can see how well it works. And now it's like a 2D object, so it will be fine to draw just a rectangle, but if I put it this way, you can see that it adapts the rectangle using the perspective, so it's higher here and shorter here as perspective transform. And even if I put like my hand on the middle, still it works. Let's try to use the other part of the book, and you see that it doesn't detect that, so it works really well. And hope is clear, and if you have any question, just write it on the comment, and thanks for watching.